Hello. First, I would like to thank the Arduino Week 2022 organising committee and specifically Sylvia Galfo for the opportunity of presenting the project today. My name is Andrew Ainger and I have been involved in IT since the 1960s. That's before it was called IT. Anyway, I started work at Plessey Research and Development Centre developing one of the first solid-state cameras. Just 100 pixels. It was very sensitive though. I moved to Rakel Electronics in London for a couple of years and then was promoted to test manager in South Africa for 4 years. Great time. Later I moved to Marconi as IT planning manager for the UK, looking after future equipment and supporting some 9,000 PCs and associated infrastructure together with 6,000 applications. The project that we're talking about today is called AWSOM. It's a well monitoring system for ongoing maintenance, and we have split the talk into 5 sections. The first section is going to talk about the technology used, or not used as well, the aim of the project, where the ideas came from, and the fourth is the time it has taken so far, and the project status and lessons learned. So, the project was intended for use in Tanzania, where Swahili is the main language. Anyway, the technology we intended to use, we didn't. We started using PLCs, relay logic, hacked talking calculator and acoustic detection circuitry. The first 2 years of the AWSOM project was spent experimenting. We tried listening to the water to derive the flow. We also tried accelerometers, ultrasonics, capacitive and thermal methods. In 6 weeks, we had a working breadboard. Very good. But it took too much power. Anyway, we did not want to put impellers or anything in the water flow, as it might attract mold and other toxins, which would be detrimental to its use. More recently, I have been fortunate enough to form a small group of some 25 senior engineers. That's hardware, software, mechanical, systems, network, even nuclear engineers have joined us to help on this well monitoring systems project. We have at least 2 things in common. Firstly, we are all retired. Secondly, and most importantly, we feel passionate enough to spend time, money and effort in developing the well monitoring system for this charitable endeavour. The aim of the project, of the AWSOM project, was to develop a well monitoring system for ongoing maintenance. The charity that requested this is the Eleanor Foundation, and they're based in Guernsey. It was agreed that we needed a day-by-day chart with time on the x-axis and litres on the vertical axis, so we could simply view the well status and provide targeted maintenance when and where needed. We also needed to check the AWSOM unit itself was functioning correctly, so we also viewed temperature, battery voltage, daily power cycle time of the AWSOM unit. We then had to take a big decision. If we were to make progress, we had to learn a new language. Now at our age, it was going to be very difficult, but we bit the bullet, so to speak, and learnt C++. Learning C++ was the best decision we ever made. It is fantastic. Within an hour of the first Arduino arriving in the post on my doorstep, we got the LED to flash. Simple, I know, but very exhilarating. We also wanted to retrofit the AWSOM unit to any well. Eventually we focused on one of our Arduino Pro Mini based prototypes using a low-cost Doppler radar. It was amazing really that the radar unit cost less than a pint of beer. Anyway, during the next 2 years we refined and tested the Arduino prototypes. We tested in the winter, in the summer, we cooked them and froze them and tried to identify their operational envelope. Testing was key. We did not want to deliver something to Tanzania that was DOA, dead on arrival. It was tempting to improve some of the already functioning modules. However, this activity was resisted as the target was to get something in country as soon as possible. The next 2 years was spent testing in country in Tanzania. Now, Tanzania is a difficult place to work, both socially, technically and environmentally. However, the full end-to-end system is now well understood and further developments are already underway. Now we've talked about the technology used, the aim of the project, where the ideas came from, charity, testing, and the time it's taken. So far, a long time. Now we come on to the project status and lessons learned, really. During the project, lessons learned, well actually, they're not learned, they're identified. It's up to the individual to learn them, but the top 5 lessons identified are: first, power. The initial experiments used a microphone to listen to the water flow and performed Fourier analysis to determine the water flow. However, the power that this took was significantly more than the photocell placed on the spout could accommodate, 10 times more. The second lesson could be summarised as: if it ain't broke, don't fix it. There was a great tendency to develop further and improve already working subsystems at the expense of further time delay. The next lesson was test, test, test. By pushing the system in extremes of temperature and environmental conditions, we felt we found and understood the safe operating environment. How wrong we were. Item 4, the next lesson was obsolescence. In hardware, which we expected, but the libraries and the suppliers, we had to identify second sources really quickly. Item 5, the next major lesson was: don't assume anything. It was assumed, for example, that all the SIM cards performed in a similar way. They don't. It was assumed that all voltage buck boost regulators performed as advertised. They don't. It was also assumed, closer to home, that all Arduino Pro Minis were the same. They are not. For example, Pro Minis obtained from alternative sources, shall we say, had the wrong bootloader installed. It took us weeks to find that. Finally, generosity. It's amazing to see just how generous the volunteers are, not only financially, but also in the time spent developing and discussing the systems in general. My sincere thanks go to all involved, all over the country and the world really, that are helping us to develop that system and continue to develop it. Conclusions? Well, we now have a well system for ongoing maintenance which is able to deliver an SMS, FTP or email 5 key data points, which are pump count, the water volume, the battery voltage, the maximum internal temperature of the unit, the number of texts sent to date, the time the unit has been powered up that day or since the last text. And all this data ends up on the website, enabling people that know the URL to provide in-country targeted maintenance to where it's needed. As for the future, well, we are already improving several aspects and are starting to adopt an Excel-based machine learning too. The daily data provides a pattern. Over time, this pattern can be determined, can help determine when the well is poorly and is about to need attention. This brings us to the neural network machine learning aspects of the project. We did produce an animal of a spreadsheet, a neural network in machine learning. Anyway, it consisted of 10 neurons, 100 neurons in the test setup, but it was painfully slow. Well, it was 75 megabytes. It's not that size anymore, and it seems to work quite well. But this is for another discussion. And finally, most of the data is on GitHub. Also, the circuit diagram, the parts list, technical and training videos, and the animal spreadsheet are all on www.wellmonitoringservice.co.uk. Well, thanks very much. Are there any questions?